Danish Academy, Thomas Kampmann, who is specializing on energy efficiency of buildings, especially focusing on energy efficiency of windows. Professor Kampmann, can you hear us?
Yes, I can hear you.
Perfect. We are here. I'm not sure if you can see us as well. There's about 30 people gathered in an old tavern built in mid-19th century. And we are all ready for your talk and presentation. So the floor is yours.
Thank you. Thank you very much. Well, I'm Thomas Kampmann from Denmark, Copenhagen, the Royal Danish Academy in Copenhagen. And I'm teaching in the students in how to measure old buildings and building archaeology and how to save energy and how to react in a responsible way concerning sustainability. And I'm going to show you our last work. We have been working together with the Technical University of Denmark. Fine. So it's a work done as an association between the Technical University, as I mentioned, out in north of Copenhagen, and the work is done by a young student called Teddy Serrano and his teacher Morten Ryberg, both from DTU and then me from the architect school. And you can see the drawings. They are done by Line D. Langkær, one of our former students, and then Daisy Kinahan Murphy, who made the web design. And the whole thing was funded by the Royal Danish Academy, and we have a big fund called Realdania, who are often giving money for projects concerning old buildings in Denmark. Well, we are architects, and we can say that architects, they know how to restore, or at least we are supposed to have that knowledge. As a matter of fact, we haven't been teaching in it for, well, we started about 10 years ago, but there was a gap for about 20 years where there were no education in how to restore old buildings. So actually we have started it up once more. When you are restoring old buildings, of course, you know how buildings are constructed and what you should do with the building. But what is the most environmental? Gives the lowest environmental impact? Is that to restore an old building, to renovate it, or to tear it down and build a new one? A lot of people would think that, or at least to tear down and then build a new sustainable wooden building. But actually we haven't found investigations done in this way. So, well, in a way it's a bit new. I want to distinguish between a restoration and renovation. Restoration, then you keep as many parts of the building as possible, all the windows, if it's possible, the doors, the roof construction, the walls. Whereas when you renovate the building, you would normally change a lot of different building parts, for instance, windows and doors. Here you have a picture of a traditional Danish timber-framed house out in the country. It is restored and it's listed, so of course it's also restored in a proper way. This building has also been a little expensive to do it, but that was Realdania who paid for this restoration. But this is how I defined a restored house, whereas a renovated house, you maybe are not thinking of the qualities of the original house. You put on a new roof. The proportions are changed very much. Of course, these two, I don't know what they look like. So this is a renovated house. Some years ago, in 2018, we got asked from Dansk Håndværk, Danish craftsmanship, because they have bought this small house on an island called Bornholm. You can see the island here. It's, I think it's the nearest point from Denmark to Estonia. And we went on a trip with our students, and we had a stop of 5 minutes, and we just had to look at the house and see would it be good to use this house for the semester for our students. And we thought, well, it was in a very poor condition, and with the roof was not very nice, and there have been changed a lot of things, but still there was also original parts kept in the house. And that's one thing. And another thing is that it's a house which is actually, you would find thousands of houses which are in the same condition as this one. So we said, yes, we used it as the semester assessment in 2019. And we went over to Bornholm with 21 students, and we started to measure the house. Normally, when we measure houses, we are using a total station, instrument land surveyors used to work with, but this time we measured the old-fashioned way with lines and measuring tape and water tubes and angular prism. So this is the old-fashioned way to measure, but it's a very good way to measure the house. You can see the drawings were made at the spot, drawn by pencil, and then later also at Bornholm transferred to the computer. We had a conservator following us. She took off each layer of paint to see how was original appearance of the different building parts. And of course, we examined all the timber to see if where it had been joined together, and how. You can see up here, it's actually, it should have been a piece of timber, but now it's just painted on the wall. So we investigated everything in the house, and we started to measure. When we start to measure, we start with measuring all the details of the house. So they are measured with an accuracy of 0.2 millimeter, 0.2 of a millimeter, and we are measuring all different parts like hinges and frames and casements. All parts, all details. When you have measured such a detail, you can see how it actually is. If you have not measured it, you cannot really tell. So you have to measure to get an understanding on how it actually looks like. From the detail scale 1 to 1, we make the details in scale 1 to 10, and it's quite easy because we can just put the hinges, for instance, up here. We have the profiles here. We can use, it's not here. We can use the profiles where it should be fit. And then we have the detail scales, the 1 to 10 drawings of the doors from inside, outside, and cross-section, 2 cross-sections. And that we can use later for making the final drawings. When you have been measuring all the doors and windows, no, not all of them, but we start to do it, then we make a scheme where we put each door and window which will have its own number. You can see D, door, and 1, it's first floor, and then it's number 2, no, number 1, number 2, number 3, and so on. And then we put all information, all important informations here. How is it connected? How big is it? How does it look like? And the profiles. And then if some part of a door is the same as an earlier one, We just mention here 1D, 1,2, because it's the same as this one. So it's easy to find, to group them, to see which one are from the same age. And in that way, also to age determine the different building parts. Last, we made the drawings in scale 1 to 50, where we, of course, use all the detailed drawings, and we could, if we have 5 windows which are the same, we can just put in the same detail on the right spot. And all treasures of earlier building stages, we could see they are also drawn into, put on the drawings. We had 3 cross sections and 2 plans and the 4 elevations and longitudinal section 2. And when we are measuring, you know, of course, we cannot look into the wall, but we try to knock at the wall and to see how, of which materials it's built of. And that's actually quite, we do that normally, but that's very important too for when we are doing this life cycle assessment. We also went into archives to find out papers on who lived in the place, and we found treasures of, you can see here, number 6. Spare number 6, and there were also some old drawings and old pictures, and we found out that way that the building was constructed in 1887. And we found out also when it was expanded, the different stages of when it was expanded. So then we were finished at Bornholm, and we went home to Copenhagen, and the students continued with their project, and I started to see how could we actually calculate the LCA, the life cycle assessment. So I chose that we should have 2 scenarios. Scenario 1, that was that we expected as we restored the house as though it would have been listed. Of course, it's not listed, it is in a poor condition, but and therefore we haven't asked the Agency for Cultural Heritage, but it's we are doing things that we expect could be allowed for a listed building. And then scenario 2, that was renovated, and it was renovated up to BR, the building legislation 2018, and then the doors and windows were changed to modern wood aluminium doors and windows. And there was added scenario 1B and 1C, and I would explain a little about that later. Having this cooperation with the technical university, we paid them to do it, but if you are paying a technical university, there are 2 levels of how expensive it would be. If you are a company asking to get the result, then you are going to pay a lot of money. But as this was a cooperation as scientists, it was much cheaper. And we had this 2 research question. 1, which transformation scenario has the lowest environmental impact? Would it be the restoration or renovation? And 2 is transforming an existing building more environmentally friendly than building a new one. That was the 2 research questions. And we used a LCA assessment as a way to find out. And we focused on the climate change, obviously. Then also we had a look at the influence of how old can a building be, and also the lifetime of building different building materials. And then, of course, it would we would like that we can use the study as an example for other similar buildings. As you can see here, it was not only the climate change which was calculated for the different scenarios, it was a lot. It was 15 different categories, but I would only talk about the climate change here. And this is the homepage where you can also go and have a look yourself later. Here we have all the scenarios. You can see the different scenarios, scenario 1, 1B, 1C, and the renovated 1, 2. And here you can see the result over here. It's given in the climate change or climate impact. It's given in CO2 equivalent per year, and it's seen for a period of 50 years, a lifespan of 50 years. And you can see for scenario 1, 1B, 1C, 2, and a new house made out of brick, and a new timber house. Now you can see it better. This was the original scenario for the restored house, and you can see on the roof we put, if we press here, the ceiling, it is with 200 millimeter of wood fiber insulation. We put new straw on the roof and tiles in the lower part. That's what how the house looked like originally. We can press on the windows, and it says here what we're doing with the windows. Here, I don't know if you are used to using secondary glazing. This is a traditional Danish window, and we have here, if we put a secondary glazing, it's put on the inside, and it's we keep the glass at outside, but on the secondary framing we put energy glass. I don't know if you know that kind of glass. It's actually the same. You can see maybe here in the room. It's one layer of glass with a thin film, a coating. It's a hard coating on it, and it would have the energy loose from the window, compared with just two ordinary glasses. But it's not a energy pane window. It is only you can see if you have a energy pane, you have two glasses glued together. They are more efficient they have a lower U value, but they wouldn't allow that much of the sun coming into the room. So this is a modern wooden window, a wooden window with, instead of paint on the outside, it's with aluminium. And this is constructed with aluminium and wood. It's, I don't know if you know a Danish roof window called Velux. They have a sister company called Velfag who are producing this kind of windows. Or it could also, a new window could also be a plastic window. And I would tell you a little about how we, what we do, how we look at the energy from a window. You can see this is the inside of the window and the outside. You would have some of the energy going through the energy through the glass. It could be the energy pane or 1+1 ordinary glasses. And some of the heat is escaping through the wood or the aluminium or how the window is constructed. And then some of the heat is disappear in a line around the window, because, and you can see as this is depending on the length of the thermal bridges. Then the smaller the window, the glasses are, the more important is this part for the energy loss. If you take those three arrows together, you would have the total amount of energy leaving the window, or going through the window in the heating season. But we would also, even in Denmark, I don't know how it is in Estonia, you are a bit more to the north, but still, I think it's not that different. Then you would have a certain amount of a sun reaching the window during the heating season, and some of this would go into the rooms and actually help heating your house. So if you take this arrow here and that one here, the difference between here, that's what you are going to make with gas or oil or coal or windmill electricity from windmills, or how you would get it. Yeah, it's just a picture of a traditional Danish window where you can see the secondary glazing is here with one layer of energy glass. If we see here the scenario 2, that's insulated with actually it's insulated up to building legislation 2018, and that would say that mean that we are using 300 millimeter of stone fiber rock wool, and because it does not work very well together with the old house, you have to have 50 millimeter of air gap between the insulation material and the old wall. So all in all, it would be 350 millimeter layer of insulation from the inside. So actually this door cannot be opened, and you cannot see, but the toilet is here, and it's very small. But well, you wouldn't do it like that, but that's just to see how it would work. And it's with new aluminium doors and new aluminium windows. And you can see here that actually the climate impact is bigger than, even though it's better insulated, it's the climate impact is higher than for scenario 1, and especially for scenario 1B. Now we have assumed that that the house were listed, and we didn't ask the Agency for Cultural Heritage. So we also made a scenario where what happened if we do nothing at all, if we don't insulate anything on the old house, no insulation at the roof, the walls, the windows, anything. And you can see that's quite bad. It's quite bad. And then I would also say that this is for the house is thought that it's heated with a heat pump, electric heat pump, and it is with an electricity mix from Bornholm, the small island Bornholm, and they are quite green because they are getting electricity from Sweden, and they have a lot of windmills. And then we calculate, we see how is the electricity mixed now, and then we say that we are going to be more and more green, and in 15 years it's going to be more or less totally heated with renewable energy sources. So I think if you look at the electricity map, I think Estonia is have a quite higher impact. You are using, I think you're using quite some coal for making electricity, but of course we are all going to change to renewable sources. So maybe you are higher now, but I think you are also going to change because of the climate price. But you can see it has a big influence how you actually insulate your house. And 2 new houses, if you tear them down and new brick house or timber house, you have the result here. And for me, actually, I think it was quite surprising that they did perform so bad compared with the existing house. If we go into this one, we can see the different part of the building. If we take exterior windows, press here, you can see we are saying what are we doing with the windows, and it's explained a bit further here for the different scenarios. If you can see that those here, the columns, if it's shaded, the upper part, that's the part of the climate impact, which are it's because of the heat loss, and the lower part, it's because of the materials used to renovate or to use to build new windows or doors. So of course the old one, it's very good because you're not using that many materials, but compared with the new doors, but on the other hand, you would have a big heat loss, and then you have to pay for that. Here in this group, it's all building parts which are subject to heat loss, and here without any subject to the heat loss. So you can yourself see what happens on the different building parts. Life cycle assessment, what is that? Actually, it is counting, and that's why it was so. When we're measuring a house, the students, they are drawing the house on AutoCAD, and when we have the drawings, we have the thickness of the wall, we have the area of the wall, and we know what they are constructed of. Then we can find out what materials, actually kilo of materials, are there in the house. So it's hard work getting all the information, but in another way, it's not rocket science. So we calculate all things which should be done for making the materials for restoring or renovating or building a new house. The materials used for heating the house in the assessment period, here it was 50 years. And then, of course, for instance, the energy pane, they can only last for 20 years, so they have to be changed every 20 years. So that should also be calculated. And then after 50 years, we demolish the house, and that would give some impact too. So it's actually just a calculation of all the different parts. What is kilogram CO2 equivalent? We have about 6 greenhouse gases, but instead of pulling them up, all of them each by each, to make it a little easier, they are compressed to see if everything was carbon dioxide, what would it then mean? For instance, you have methane, natural gas, or biogas. It's 28 times more impactful than carbon dioxide. So 1 kilo methane equals 28 carbon dioxide equivalents. And to try to see what this mean in a daily life, it was the young student from DTU who make this. It equals average human emission for 8 days, or 1 hour in an airplane, 400 kilometers in a car, buying the production of 2 new smartphones, 16 meals including beef, 193 vegetarian meals, streaming 3 seasons of Game of Thrones, or if you have a big garden, then you can pay back by having 5 mature trees in 1 year. So uptake 100 kilo carbon dioxide. House lifetime, it was, I think it's very, I don't know how it is in Estonia, but here in Denmark, there's often a fight between engineers and architects, and we are not very good at cooperating or maybe just talking to each other. So therefore, I think it was very important with this cooperation, and very fruitful, because I guess that Morten and Teddy were quite surprised about things I didn't know, and then I could see that actually they didn't know anything about how an old house was constructed. And in the start, you know, they said that we should calculate for 50 years. And then I said, well, 50 years, scenario 1, we presume it's a listed house. It's already 135 years old. How can we say that we should tear down after 50 years? It gives no meaning. So we also made the calculations for 100 years. But on the other hand, when we were at Bornholm in the spring 2019, nobody knew anything about invasion of Ukraine or COVID. It's very hard to look out in the future. But on the other hand, buildings are lasting for a long time. It's not a car. It's not an airplane. Buildings tend to have a much longer lifetime than many other things we are producing and living together with. When we are looking out 100 years in the future, it would be even more important to look on the material lifetime. How long time can a brick last? Here it's official lifetimes from something called BIL, the Danish Building Institute. They have those lifetimes, but for instance, they don't know nothing about traditional houses too. So they say that all glass should be changed every 20 years. And I said, well, we have the old house at Bornholm. We have glass, original glass, 135 years old. A glass is not going to be old. So I said, well, if we traditional glassing, it could be last for 100 years at least. So we have the official lifetimes for material lifetime, and then we have lifetime here based from experience from restoration architects and what we could actually find at the spot at Bornholm. Because what we can do as a restoration architects, we can look at a building part, we can examine which condition it is in, we can describe if it can be repaired, and if it can be repaired, how it should be repaired, and also how it should be maintained so it can last for many years more. For instance, using linseed oil instead of plastic paint, not using concrete, but using lime, and things like that. When we here are calculating for 50 years, if the lifetime is shorter than 50 years, then it has to be changed or repainted. And of course, when we have 100 years lifetime, it's much more we have to do. We have also made the calculations for restoration architects lifetimes for 50 years assessment period, and for build material lifetime for 100 years. But we, in this on this homepage, we are only showing those two, because else it would be too complicated to show. But when we go back to this, you can see that when we are having this 100 years lifetime, you can see that the restored house, it's much better than the renovated house. We didn't make the calculations for the new houses, but it was 2 PhD students from the Technical University, with also Morten Ryberg as advisor. So they are okay, the calculations, but we didn't make them for this project. But you can see, what if new houses cannot live for more than 50 years? Actually, we have many new houses in Denmark. We tear them down because they are in a very poor condition after a few years. Then you would have this doubled up, and then suddenly it's very, very, it's absolutely the best to restore, even to renovate, but the best is to restore the old house. Actually, I think they are talking about absolute sustainability, and that would be that it shouldn't give more than 1.8 kilo carbon dioxide per square meter per year. And as the house is 204 square meters, it would here be that it's actually 1.78 kilo carbon dioxide per year per square meter. So we are near to absolute sustainability. Project background, yes, one can wonder what went wrong going from this house, from this appearance to here, but yeah, that's how things goes. And who made the project? You can see it here. So are there any questions?
Thank you very much, Professor Kampmann, for your presentation. It has been very, very interesting to listen to all the absolutely detailed work that was done. So let's see if we have questions immediately in the room. If not, if I can lead off with one question of my own.
Yes.
How transferable do you think the central conclusion about comparing the restoration of the house versus renovation versus building a new house in terms of the CO2 footprint? You chose a particular house on Bornholm, but
yeah.
Can you transfer those results to any comparably old building in Denmark, or perhaps could you also even transfer those results to any comparably old building in Estonia? How much can you transfer those results to?
I think that a conclusion from the work is that this kind of investigation should be done on many types of houses, because if you have what about a house only being 20 years old, made out of concrete? How would that look? If you had a house totally in brick, or you have maybe houses totally made out of timber. So I think it's hard to say how you can compare it, because actually you should do the investigation. Actually, this kind of investigation should be done for 10, 20 typical buildings for each country. And of course, I think a lot of when you look at the building, you can see that, of course, if it's made out of brick, that as our houses, and with some timber in, it's going to be very, very cold in the winter time. And I think if you have on your I saw you have some timber house. If you have such a house, it will also be maybe a bit better insulating, but it's still not very much. So the first 75 millimeter of hempcrete or another kind of insulation would really make a big difference. And also, I think it's very important that you are using materials which are works together with the original materials in the house, so you wouldn't have moisture in the construction and it would start to rotten. It's very important not to use plastic painting or you put concrete on the outside of the house. So I think but it's, of course, it should be calculated, but I think it would still give a good idea for you can say a one-family house or smaller house like this.
Okay, thank you so much. Kas meil on teisi küsimusi?
Have you considered the change of heating systems and ventilation systems?
Yes, we have that. It's not showed here, but actually we tried to calculate if the house was heated with natural gas, but there's no natural gas at Bornholm, but still we did it, and with 2 or 3 other heating systems. One could say that using a heat pump with electricity from Bornholm, it's rather green. But on the other hand, actually, it could be better because we are using district heating too. And even at Bornholm, even though it's out in the country, there is the pipes are just out in the street. So if you're using district heating, I don't know if you are using that in Estonia, where you have a central power plant, and it could so just now in Denmark we have a storm. You could use the electricity with a huge heat pump at the power plant to produce the hot water. If the sun is shining as yesterday, then you would use the electricity for also making from the heat pump. And then if there's no wind, no sun, then you could maybe have a biogas heated system. So you have a lot of different kind of energy sources you put into the system where you heat with just hot water you take from the street, from the pipes in the street. District heating.
Okay, thank you. Kas meil on veel küsimusi? Inglise keeles või küsida põhimõtteliselt eesti keeles, ma võin proovida tõlkida, kuigi ma võin terminitega. Nii, jah.
Ühistuskulude võrdlus restaureerimine ja renoveerimine ja samas mahus täitsa uue ehitamine. Protsentuaalselt või kuidagi.
Professor, there's a question about costs. If you can comment on this, the same scenarios of renovation versus restoration versus constructing a new building. Can you comment on costs at all?
No, we haven't calculated on that. Actually, it is being restored now because it's being restored by the Danish craftsmanship, because they are using it as an example, so the young people can come and try to do it. But we haven't made the calculations. But I think also it's very hard to make those because what do you know? This one, how much does it cost? Because it really depends on how people are starting to work with such a house. And also, no, we haven't done, but it's not so that it cannot be I think it would be cheaper to restore the house than to renovate the house, because we are using, we are not, the building parts, the new doors and new windows are actually quite expensive, whereas the doors and windows, they can be repaired quite cheap. Bigger windows. I've been participating in a huge building in Copenhagen with windows, also old windows, but bigger than this one. And it cost, well, actually now it's 10 years ago, it cost 5,500 Danish crown per window. So what would that be in euro? Maybe 800 euro. And that was without tax, but including scaffolding to reach it. So I think it's more or less would be the same price for the renovated as for the restored house. But it's really, it can be really hard to give a price, because it depends on the people if they're used to work with old buildings. If you're not used, you don't have the skills either as an engineer or architect or the craftsman, then you would see only problems in restoring a house. And then it would be expensive.
Okay, there seem to be no more questions at this point. So thank you very much for introducing this incredibly detailed calculation and interesting work, Professor Kampmann.
Yes, thank you very much. Yes, bye bye.
Goodbye.
Bye bye.